Basically what it was that I was looking at on morphology, urban areas, and my interest is in basically right now my interest is in climate change issues. And I will just give a short snippet of what I did, but generally I hope I've broken down, because I know that there are people who are not in our field who are currently in the presentation, so that you get to understand. So I will close my video, stop my video, and start screen sharing. Okay. So for today's webinar, it's about modeling the urban morphology and quality from photogrammetric methods. And this, I will be looking at different aspects on what we refer to as morphology, because I got very many questions. What do we mean? And a bit about photogrammetric methods, not too much, but I will highlight everything and try and give a breakdown. So the outline of the presentation is that a brief introduction. I'll cover a bit about urban morphology. What do we mean about urban quality of life? What are the factors that are considered? And then a bit about climate change, where we'll be looking at talk about surface urban heat islands. I think the urban heat island is a terminology that is mostly used, but in analysis, especially if you're in the geospatial field, what do you look for? Which particular aspect of the urban heat island are you looking at? And then we'll look briefly at spatial modeling, a case study which will be derived from the project, and then a conclusion. So a brief introduction is that what do we refer to as urbanization? This is where there are processes that tend to act on the physical geography. So this could be because of political forces, social and cultural forces, things about demographics, and that's why every 10 years is a census that occurs, as well as environmental and economic processes. This all affects resource consumption and the population at large. So that is what we refer to as urbanization. So one thing when it comes to urbanization, urban planning is very integral, because it tends to design this urban space, this particular space that we have, where there are certain areas where certain activities are located, and especially when you are having buildings that are being set up. And right now, I think the trend is the higher we go, that is the direction that we're going. And there's a lot of talk about compact cities. So urban planning is very important. Why? Because the way we plan our cities tends to affect lighting, solar heating, because of urban geometry. So what will happen is that depending on the way that the cities are developed, then you'll tend to find, for example, if there's not much lighting, then there will be a greater increase of, for example, people will always be having their lights on during the day instead of making use of natural lighting. So in urban growth in Kenya, we'll find that it is estimated that around by 2050, we'll be around 60 billion people in the world. And the rate at which we are growing, especially in the urban, most people are moving out of the rural areas to urban areas. And with this, there's increased development. So other than just looking at how many people are coming in, what about looking at our urban structures? So yes, people are coming in, and because there's a force that is there that pushes development and buildings to be set up. However, there's still greater need to understand that regardless of whether we have said, for example, we need compact development, there's need to understand that, for example, Kenya's climate is very different from anyone else who is in the northern areas and the southern parts of the equator. So then this urban development needs to be looked at in a scale-wise manner, so that then we are able to not only adopt certain strategies and certain criteria from another section, but we are able to look at what is happening within our country. So Sorry, I'm trying to get the screen a little bit. So what do we refer to as urban morphology? So urban morphology is where we are looking at the city form. So you're looking at the shape of cities, you're looking at their function, we're looking at their layout, we're looking at the street patterns and so forth. And why this is important is where we have zoning laws. So there are certain areas where you're not going to put up a certain building up to a certain height. So why? Because you're trying to control the height to distance ratios between the buildings, so that, for example, if it's a hot day, wind is able to, let's say, like carrying out of pollutants, heat, and so forth. So that is why zoning laws are very important and very key. So what you need to do is, for example, look at things scale-wise. You try and look at things scale-wise. So, sorry, Francis, is it possible for you to take the admittance of people kindly?
Yeah, so thank you. So just ignore when you see them, just ignore. It's because you're a co-host, so when I'll allow them in.
Okay.
Just ignore when you see
All right,
them.
thank you.
Yeah, thanks.
All right, okay. So with this, especially for the zoning laws are very important. So when it comes to urban morphology, you're able to look at what's the percentage of pervious surfaces and what are the pervious surfaces as well as impervious. So when we refer to as impervious, we're not only concentrating on the buildings, but the walkways are equally important. Because, for example, if a building is next to a walkway, then there is a reflectance that occurs. So the people who are probably inside the building will tend to feel a little bit hotter if, for example, there was not a pavement that is an impervious surface, for example, if it was bare ground or trees or bushes and so forth. So that is why when the urban morphology, you're able to break this down into a particular section that you're looking at and break them down into their own structure. So what is the urban quality of life? So for example, in Nairobi, we have different areas and sections, and certain people, why do you choose where you want to live at? Because there's a certain quality that you're looking at. So it can be interpreted as a fulfillment that a person gets from their physical and human conditions. And this is scale dependent. That is, it can be from a neighborhood level, individual, it can be from a township, citywide, it can be village-wise, and so forth. And this quality of life tends to influence the opportunities that a person attains. So, for example, we all come out from different areas, and sometimes some of the decisions that we make about where we live, there are certain factors that we're looking at. So, in our cities, when we're looking into the urban morphology, urban areas, the structure actually affects the urban quality of life. So you've had of very many people in cities whereby they feel very depressed. They have very many resources, but because of the way it's the structure of buildings and so forth, people actually are not emotionally happy. So you find that probably people who are in the rural areas actually tend to have a better quality of life more than those who are in the urban setting. So what are these factors that could be considered when you're looking at the urban quality of life? So there is health, there's security, personal development, there's also community development, natural resources, and the physical environment. All these tend to generally form what should be looked at when you're regarding an area having a good quality of life. However, the social, economic, and environmental factors mainly form the three main pillars of the quality of life. For this study, we'll be looking at both the urban areas, that is the urban morphology, the structure of buildings, and also environmental factors. And this environmental factor that will be looked at is, what are the land use, land cover changes that are there? For example, what's the greenness of an area, as well as climate? So this is one of the things that were key in, and this can be a connection to the quality of life. Okay. So moving forward, what is climate change? We always talk about climate change and so forth. So cities have mainly been attributed to be major contributors to changes of temperature. And we know that if at all we have, let's say, an increase in sea level of up to about 2 meters, then we'll have many of our coastal towns disappearing because of that. So it's a great thing that we need to look at. And these changes tend to affect and actually put urban residents and greater assets at risk. So it is important for us to understand what's the implication of our urban development, not only to human health, but also to our assets. There's this aspect of thermal comfort. How comfortable are you inside where you are at? So if you are in a room and you constantly need to have, let's say, an air conditioner, then we are actually exacerbating the issue of climate change, because the air conditioners are also not very good, especially when it comes to air temperatures and also when it comes to pollution. So these are the things that we need to look at. So urban heat island is a terminology that is mostly used in relationship to climate change. And why so? Is because then urban heat islands have been defined as the thermal differences between rural and urban areas. And the reason is because of the type of cover that we have in urban areas. So mostly concrete, and people normally term urban areas as a concrete jungle. So because of concrete and their properties, during the day it tends to absorb, because it has a high thermal capacity. So it tends to absorb the incoming radiation and it stores it. So what happens is at night, so it absorbs the incoming shortwave radiation. At night, it emits it in form of longwave radiation. So in city areas, at night, it tends to become warmer compared to the rural areas. Why? Because the rural areas is normally green grass, forests, probably open grounds. So what happens is that during the day, the rural areas, it absorbs quickly like land, and easily emits or releases the energy or the incoming solar radiation very easily. So that creates a very big difference between urban areas and rural areas. So the rural areas tend to cool quickly from evaporation, plant transpiration, compared to urban areas where there is less cooling from evaporation and plant transpiration. So we have three types of urban heat islands. So we have the boundary layer urban heat islands, which tends to be a little bit further up. We have the canopy layer, which tends to be between, let's say, the tops of buildings to the ground. So sometimes you will find that some researchers, if you're trying to find out what's the air temperature, you'll put, let's say, a thermometer on a vehicle, which is about 2 meters high, and then drive through streets and so forth. So what you're trying to do is, the reason why it's 2 meters up is so that then you're not having an influence from the ground. The third one is the surface urban heat island. So with the surface urban heat island is where mostly remote sensing techniques are used, because you don't have to be in direct contact compared to, let's say, canopy layer urban heat island. So with the surface urban heat island, you're able to determine the surface temperature. For example, if you have trees, you have the rooftops of buildings, the roads, the pavements that people are walking on. So those are the three urban heat islands that we have. And for this study, my focus will be, and for the webinar, my focus will be on the surface urban heat island, because here you're using remote sensing techniques to be able to detect the surface heat. So with surface urban heat islands, they tend to be very large during the day, both during the day and the night. So this is an illustration of the boundary urban heat island, and this is the canopy, and this is the surface. So for the surface, these are the buildings that are being seen. The surface, this is highlighted in red. So the surface urban heat islands are mainly well analyzed by using the surface temperature. And this surface temperature can be explained by urban structure and forms, by the shape and the size of building structures. So you'll know, if you look at the surface, land surface temperature, you'll find that the heat in certain structure of buildings whose roof type whose rooftop is of a particular size will be very different from areas where the rooftop, for example, is very wide. However, when you look at that in reverse, let's say at night, you will find there will be a reverse. For example, areas where the rooftops are the buildings probably are a bit short, and the roof surfaces are a bit, let's say, a bit wide, not so much. Sometimes during the day, the surface temperature will be higher, but compared to those that have very tall buildings and narrow rooftops, at night the reverse can occur. So this is why the land surface temperature is very important for one to understand what is the behavior of different structures and different forms, and it will help us make informed decisions, especially when it comes to planning in the way we build our cities. So what's the influence of urban forms on urban heat islands? So that is the main focus. So the type of urban forms, so this is a typical city. So we have people who are in buildings, we have cars that are driving. So we'll find that, of course, where there are trees, it tends to be cooler in comparison to where it's definitely a concrete. And also in how research has shown the way the roads are built, they also actually have an effect on the surface temperature. So if you have a very thick, let's say, pavement, what will happen is that you've created a greater surface for absorbing incoming radiation. So this particular thickness, especially when it's looked at night, you've created a greater capacity to absorb incoming radiation and store heat in comparison to if it is very thin. So because of the sunlight, there is a reflection, for example, that occurs from incoming radiation, hits the surface of the wall of a building as well as the road. So for most people who have walked, driven Uhuru Highway, I've forgotten the name of this building, especially buildings that have glass at midday. If you're passing there and maybe, for example, there's a jam and all the cars, vehicles stop, or probably you're even walking along there, it tends to become very, very hot, especially if it's paved on the ground. Why? Because of that reflectance. So the material types, even the heights of buildings, have an effect. That is what we're referring to as the urban form, have an effect on the urban heat island effect that we have, as well as these other human activities that occur in urban areas. So the surface temperature of urban structures tend to be higher than the ambient air temperatures that we have. So this is what one needs to understand, and also what kind of land cover should we have. So you find like water is equally very good because it tends to absorb and allows the temperatures to go down because it has also a high thermal capacity. So what we will be doing is modeling. You need to model spatially. What we mean by modeling spatially is you're trying to understand the dynamics that occur on the ground in different areas. So an example, I'll give the example of Nairobi. Nairobi is diverse. There are different urban forms, urban structures, and land cover. So regardless of, for example, experiencing the same sun, but different areas have different interactions with incoming solar radiation. So you need to interpret this pattern. So if it's the northern part of Nairobi, what's happening on the southern part, on the eastern part, or on the western part? So what you're doing, you're examining changes, the dynamics of these changes. To what magnitude are these interactions occurring? Could there be other factors that are existing? So the spatial metrics that can be derived because they are diverse. So you can either decide to make use of spatial metrics on a two-dimensional plane, that is just the X and Y, or you bring in the third dimension, which is the height. So you have the 3D spatial metrics, so that then you can have a link between the physical landscape and the urban form. So one of the aspects that that goes into it is, for example, you want to try and generate a 3D city model. So there are various sources of developing the 3D city models. One way is by either using stereo aerial imagery, or you can use satellite stereo imagery. There are different sources that are there, but it all depends on, I can say sometimes it all depends on availability or depending on the level of accuracy that you want. So that, for example, if you're using in urban areas, so definitely you'll need a higher level of accuracy that is spatially. So, and at the same time, you develop these indices that can help in having, for example, the building density and then 3D expansion index. These are 3D indices that have been developed for the 3D city model. So once you develop the 3D city model, first you've gotten from photogrammetric techniques. I will summarize the process in another slide, but from here it's just an indication of the different sources that you can obtain. And one thing that is key, especially when you're studying urban areas, is multi-temporal data sets. So what it means that you're able to monitor changes that have occurred in urban areas from within different time series. So for example, you can start from 1970 and understand what has occurred on the ground. And then probably in 10-year intervals, so 1970, 1980, 1990, 2000, 2010, and 2020, then you are able to understand what are the forces that are driving development in urban areas. So you'll find that probably with time, the different types of sources of data that are available for you will be different, as well as probably the level of skills. But at the end, you'll be able to understand, the kind of processes and forces that are occurring on the ground. At the same time, though I did not indicate here, there are also other remotely sensed data sets that you can obtain, for example, from satellite data that is not high resolution. From the aerial imagery as well as from satellite sources, which have high resolution, then definitely you'll be working with up to about 10 centimeters. So an example is one which is here, the data sets that you're seeing here, they're up to about 10 centimeter types of data. So that is very high level. But probably, for example, for those that are freely available, open source, then those ones you can obtain them probably 30 meters and probably, let's say 30 meters from Landsat. That one definitely you will not be using it to analyze urban forms and urban structures, because you'll not be able to determine the edges of the buildings. So definitely what you're interested in is the building edges, as well as when it comes to their height and so forth. So what goes into generating 3D models? So the illustration that you're seeing here towards your right, this is a digital elevation model, and this area of study is upper hill. So there's a difference in elevation. So it shows that towards the eastern part of upper hill, which is green, that is the lower portions, while the red areas, which are the higher parts in terms of elevation, that is above sea level. So one of the main ways, how do you go about generating a 3D model? So what you want to do is, like for this previous slide, this is the data sets that you have. You've purchased it from whichever provider. Then what do you do? Because this is what you have. So it has no coordinates at all. So you need to go to the ground and collect ground control points. That is if probably the provider will not give it to you. So of course, they need to be equally well distributed and over your study area, over the area that is of interest to you. And then, so it allows you to georeference the aerial photograph. So what means is that there is, for georeferencing, it means that you have this image, but it has been referenced to the Earth's surface. So the coordinates that you will get from this particular image are true representation of what you have on the ground. The next thing is definitely you need to generate a digital elevation model. So the digital elevation model allows you or indicates the height above mean sea level of the bare earth without any other things, for example, like buildings and so forth. So it's a bare earth. So why this is important is because you will carry out, you need to find the building heights. So the building heights is because each building rests on the surface of the earth. And this is why the digital elevation model is very key and important. So what then you will do is definitely, I'll go back to the next slide, the images that are in the middle. So for example, this is what you have. So these are the buildings and that is what you're interested in. For example, if you are able to see the roads, yes, you can calculate the volumes of roads because if you have data sets, for example, from, let's say Kura, or not Kura, sorry, I beg your pardon. From, let's say, yes, from Kura, for example, then you can get the dimension and the width, and probably they can tell you how thick the roads are. Then you can get the thickness, for example, in terms of volumes. So you digitize all the artificial or whichever surfaces that are important to you. Then it means that since each building, the top of the building has a certain height, you can subtract the height of whatever it is that you have digitized that is of importance to you. For me, my target was buildings. So the top of it, the buildings, as well as the digital elevation model, which is at the top, which will give you the heights of different features that are important to you. Then at the end, then you can calculate the building height, the area, the volumes. And for me, my focus right now was buildings. Okay, so there could be any other thing that could be important to you. So if, for example, if you get LiDAR, then if trees, the volumes, the types of trees, the volumes, the heights of trees, and so that you can get the types of trees, that could be a direction that you can take. So for what it was for this particular study, I used stereo aerial images, but that is not the only source. So you can get LiDAR, for example. That will give you something that is a lot more detailed about your area of study. So I'll look at a case study, and this is what that I had looked at. And this was looking at 3D built-up volume densities. This is just looking at the morphology and surface urban heat islands, because the main interest was to understand, we are developing, yes, buildings are coming up, but what's the impact of our urban areas and what's the interaction with, especially when it's hot, okay? Now, because of availability of data, it gets to restrict you. For example, right now when it's raining, then you're not able to acquire or get access to information, especially when you're using satellite imagery, especially when it's cold. So probably one can fly a drone or one can fly a plane that allows one, especially when satellite images are not available because of cloud cover, you can fly, you can use a plane, and it will allow you to get the surface temperature of objects. That can be an alternative. So one of the things that were important is to try and get the land cover changes. So my study area was Upper Hill. And the reason why Upper Hill was an area of interest is because it has seen a lot of changes in dynamics. And because of the pressures that are occurring of urbanization, we've seen Kilimani, Kileleshwa, those areas have changed completely. So Upper Hill was a good place to study. And so one of the first steps is to understand what are the changes that have occurred over the years. So this is just an indication of what happened. That is from 1986. Because of availability of data, more or less five-year interval. So this is just an indication of the changes that have occurred. So there's built up forests, sparse grassland, water, and open grassland. This was an understanding first, what kind of land cover do you have? So from 2005, 2011, and 2017. So from 1986 to 2017, if you looked at the area, it showed that there had been a greater increase in built-up areas of a very high percentage of over 20% from 1986 to 2017. And one of the areas and the land cover that was greatly affected was forest land cover. So then you can easily say that there is this level of percentage of forest cover. So forest cover has reduced from 1986 to 2017 by over 30%. Okay, so by over 30%. So those are the changes and the dynamics that have occurred spatially. So that is why when we talk about spatial modeling, it's trying to understand what is occurring at different parts of this area of interest. The next thing is to get the land surface temperature, because we're looking at surface urban heat islands. So the same thing from 1986, 1995, 2000, 2005, 2011, and 2017, the same period. So within the same period, then you can see the areas where it's cooler, where it's hotter. Have there been changes in terms of the minimum land surface temperature that has been seen over the area? Is there also a change on the maximum land surface temperature that has been seen? So this is what we mean by trend analysis. Then you can understand some of the forces. Why is there development occurring probably in some central parts of the area? What could be attracting people in certain parts, for example, of Upper Hill compared to others? So this is just a summary of everything. So the next thing is developing 3D built-up models. So previously I had talked about stereo aerial imagery. So from the digitization of the tops of built-up areas, so then you're able to classify. So in the building code that we do have, is that there is a certain level. If you say a building is low rise, middle rise, and high rise, how high is it above? How high is it? So for example, low rise is a building that is not more higher than about 3 meters. Middle rise is from about 3 to 10 meters. High rise is a building that is higher than 10 meters. Density has also been defined. And so the area has been classified based on its density as well, and the buildings based on the height. So this is as well as trend analysis from the past to the present. So what you're currently seeing is how Upper Hill used to look at in 1978. This is from a stereo aerial image. The second one is from the year 1998. So there has been some bit of more development. The area that is towards the west, there's not too much changes because this is institution. This is Kenyatta National Hospital. To the northern part, there's some bit of development. So buildings generally are still within low rise, less than 3 meters or so forth. And then this is how it currently looks then in 2017. So there are more high-rise buildings, and there is a greater increase in middle-rise buildings. So you can see that the development tends to occur in certain areas. So these are the forces to try and understand why does development occur in a certain way. So some of this, I think I'll talk about it in the next slide. So some of the indices that are generated, because what you want to do is to understand, though there's some bit of mathematics, this is just to try and explain that we are planning for an area for a piece of, for let's say plots of land and so forth. So what you need to understand is, for you to say an area needs to be this level of density, that buildings need to be this high, then you're having a certain reference point. So a reference point can be an area of a plot. So probably you're told you can only develop it 50%. So if you're only told that you need to develop it 50%, then what's the basis? So this is the area of the plot. So you can have a ground coverage ratio. This is when it comes to the building footprint alone. So that is the ground coverage ratio. So this is just 2-dimension. Then we have what we refer to as a plot ratio, also referred to as a floor area ratio. So this is the height. So how many floors are there in this building? So that's when we're referring to as a floor area ratio. And then the volume density. So you have a building, it has a volume because it occupies a certain space. So with regards to this, I'll go back to the previous slide. It becomes sometimes difficult to try and get in some areas, for example, let's say parcel information. So the way that for this, it was just dividing it in terms of grid. So the grid was what took this place of reference, that is the area of the plot. Okay, so that is how, if it comes to the ground coverage ratio and the plot ratio and the built-up volume density. So the main thing of the study was to understand this volume. So a building probably is very narrow and very tall. So another one is very wide and very short. Do they interact in the same way with, let's say, with are their surface temperatures the same? So there could be other factors that are there definitely which play a role, for example, material type, what kind of roof do they have and so forth. But generally, this building that you have, how wide it is and how narrow it is, does it have an influence? So what you need to do, we previously talked about spatial modeling. So what you need to do is to try and understand the dynamics that are occurring on the ground. And so the modeling techniques that are there, we have mainly two. We have linear and non-linear. One of the linear one is the ordinary least square method, and the non-linear is geographically weighted regression. So we have those two types of methods of analysis that I mainly used are linear and non-linear. And why non-linear is used is because an area is dynamic. Geographical aspects, some of them are difficult to say that they behave or interact with each other in a linear way. They are very dynamic. So the main aspects was to understand, for example, the NDVI, that's trying to determine what's the health of vegetation, and the land surface temperature. Then we have albedo, that is the reflectance, which is based on the material type. So we have forest areas, we have water, we do have things like concrete and so forth, as well as the aspect, that is the direction of the slope. So because the sun rises in the east and west and sets in the west, that you'll find that areas and slopes that face towards the east, where the sun is tend to warm up faster compared to places which are more westwards in relationship to the sun, then they do not tend to warm up very quickly compared to the east. So these are the aspects that, or rather the things that were mainly looked at, okay? So generally at the end, there was each of these variables, the built-up, BVD stands for built-up volume density, was analyzed together with each one of these other variables that are there. So I wanted to understand, as from 1978 to 2017, could have had a greater impact when it comes to the building. Is it its height? Is it how wide is it? It is, or is it the entire, when you combine the two of them? So in 1978, results showed that the height tended to have a greater influence in relationship to the land surface temperature. Okay. In 1998, it was a built-up volume density, the same thing in 2017. So what you're looking at, I know there are very many colors, but in summary, we have what we refer to as the R squared. So it tends to show you the strength of the relationship between the variables that you're looking at. Remember, we've talked about spatial modeling, and you want to understand in this urban area and these other variables that you're looking at, what's their spatial relationship? Certain areas will tend to have a greater relationship than others, probably because of, for example, in 2017, the central part of Upper Hill showed that there tended to have been showed somewhat of some bit of great relationship compared to other areas that are built up. So some of the explanations could be probably because the central part of Upper Hill tends to have one of the tall buildings that are there. So what's the urban form and urban structure? What could be these other urban dynamics that are occurring? So that means that at least you've picked out something for further interest and further investigation. So in conclusion, with all that I have talked about, why would one try and do any modeling? Why would one try and find out what's the relationship between? Because the 3D information helps you analyze dense building structures. So you'll tend to understand that because compact development and compact cities have been seen as an ideal form of sustainable development. However, from what we have seen from the modeling results, it's that one would need to look at this compact development in relationship to the land surface temperature. So probably because we're here in the tropics, it could be equatorial region, it could be different from those who are in the tropics. So it's good to understand and analyze areas and understand the dynamics that are occurring. So also to understand the needs of adaptation so that then we can become a resilient and sustainable city. And one thing that is important is because sometimes some of the data sets that are needed to carry out modeling are quite expensive to occur. So it has shown that, and there's greater need to use open access data, for example, like Landsat for land surface temperature. Then it can allow consistent analysis of urban areas, especially if you have open access data for trend analysis. And when it comes to environmental management, especially of our cities, it shows that there is, especially when you do all this, it indicates that there is greater need of emphasis of greening in our cities. I know there has been a lot of talk, especially with the building of the highway. I will not talk much about it, but there has been a lot of talk about it. When trees were cut, there was a significant feel. People felt the impact when these trees were cut. So what else can we do? There needs to be greater influence. And with this particular type of data, then we are able to show with proof and with data that there is an impact when we are developing in a certain direction, and probably we may need to change our trajectory or not. Okay, thank you very much for listening. And if there are any questions, feel free.
Okay. Yeah, so thank you so much, Patricia. Maybe you could just put your photo for those who came late so that they see the voice, the face behind the voice.
All right.
So thank you for the presentation that you've just made.
Okay,
I know Michael Makoha's hand has been up, and so I don't know that it's a question that you want to ask Michael, because now for the next 15-20 minutes we can have a discussion on the presentation that Patricia has been able to make. Michael, do you want to speak?
Yes, Daktari. I think it's Daktari.
Yeah.
Okay.
Dr. Oloo was my teacher. I don't know if you remember.
Okay.
Yeah.
So what's your question, Michael? I remember Michael. I remember marking exams for Michael.
And my pleasure to meet. I wanted to know a method that Patricia used to do the land cover.
Okay.
Like what you used to perform the land cover change. And then I didn't get clearly what was the source of your tri-stereo, or stereo images.
Mm-hmm. Okay. Okay. Yeah. So thank you.
The source, and also it was not
Okay. Michael, think, Michael, we are not able to get you well, but we got the first part of the question, so I'll just ask it again. Okay. Yeah, so Michael is asking. Okay.
Am I clear?
You are breaking, but we got the first part of your question. So let me ask it, and then Patricia can be able to answer.
Can I complete Daktari before, so that I don't speak again?
Okay. Yeah, it's just that you are breaking, but try. You are breaking, so try again.
Okay, what I was, I think the first one you got it a bit. That land cover land cover analysis method she used. The source of stress, the
Okay.
stereo.
Yeah.
Images and the resolution. And I wanted to know, why did you decide to use the NDVI to
Okay.
assess the method, like for example, people to change the construction method. You can build a story building, but at the top, there is a way you can be able to allow space to build to grow vegetation on top of building, so that as much as you're optimizing the ground, we are still managing the effect of climate change from the top of the building. Thank you.
Okay.
India.
Thank you. Okay, so Patricia, there's a question from, and by the way, Patricia is Dr. Patricia Mwangi. So for clarity, it should be Daktari. So the question from Michael, which I want to link to a few other questions which have been asked, and then I'll give the next set of participants to ask questions.
And the last one is that
okay.
Maybe a thought.
Okay. Okay. Yeah. So one is on the methods for the methods for land use, land cover, and then what was the source of stereo imagery that you used? Okay. Michael, please, if you could just if you could just type your question, because you are breaking up.
Yeah. To assess the okay, that's fine. I will type.
Yeah, just type. Yeah. So, but the points were land use, land cover. What were the methods? What was the source of your stereo?
And not maybe another index like NDII, because.
Okay. So Patricia, maybe just try to handle the questions from Michael first, and then we go to the others. You're muted.
Sorry. How I did the land cover first, mainly for the source, I used Landsat. That was my source of data, a 30-meter resolution. But because of availability of data, because I was working within a particular month, that was mainly January and February. So because of lack of availability of data, I also used ASTA as well for about 2 years. For the method of land cover analysis, I used random forest. So that one was some bit of coding. I used RStudio. And then once after that was generated in RStudio, then I imported it in ArcGIS. So the main software for use was ArcGIS. So once that was generated in ArcGIS, then the other analysis was done. So stereo imagery, I purchased it from Ramani. So that's aerial imagery. The resolution was at 10 centimeters. That was for 2017. But for 1978, I used, it was acquired from Survey of Kenya at the same time. So for 2017 from Ramani, it was digital form. The other was, can I call it analog? So it had to scan and then digitize. So it was a bit different. And so mainly those were the sources of data for stereo imagery. And then the scale was 1 to 25,000. So that was the scale of use for 1978, 1 to 25,000 and 1 to 50,000. And then why I used NDVI, because NDVI for me, it was for vegetation. So when modeling the two variables, I wanted for each pixel that was there, for my interest was the amount of vegetation, because based on the analysis, over 30% change of forest cover, it would be important to, for me, my interest was mainly vegetation. So that's why I used NDVI. Of course, there are various others that can be used, but for this was with NDVI for urban greening. Of course, yes, there are different ways, and there's need to advocate for green rooftops. But it's quite evident, like for Upper Hill, it's not there. There are no green roofs at all. This is because each and every building was digitized. So definitely, definitely it was seen. So I've seen that he has typed, what was the method? Why NDVI, not NDII? You can still use NDII. The balance between development and environmental conservation. So I didn't write it here, but definitely the conclusion was that there is need for environmental management. There's greater need for emphasis of open spaces. And one of the things that is there is when it comes to forces for, when it comes to different types, especially for in urban areas, the type of trees that are grown in an urban area are very key, because different trees have different strengths. And for example, there are certain trees that have been planted in certain cities because they are very good in removing pollutants from the air. So those are the things that are needed to be looked at, because you just don't plant a tree. There's some trees, if you plant, actually, that they will be even detrimental in an urban area. Because one thing is that you need wind to flow. You don't need air, for example, by the roadside. Of course, trees need to be planted by but at what distance? What kind of tree is needed? You don't need one with a very large canopy, because that will be a very good storage of let's say, heat and emissions from vehicles. So yes, there is need to grow trees. And that's why I mentioned about currently the trees that have been cut down for the for the overpass that is being built. There has been significant, people have been taking temperatures on the ground. There has been a lot of talk about it. So there has been a significant change because of cutting down those trees along Westlands, Uhuru Highway, and so forth.
Thank you. I'll give Malachi, his hand has been up for a while, to also ask a question. Malachi.
Thank you, Daktari, and great work by Dr. Patricia. Malachi Odongo, I teach 3D cadastre, and this has been a very good presentation from Dr. Patricia. The only thing that I want to ask is that why could we include also the parcel, the cadastre, other than integrating the temperature, the heights, the land cover? Could you also take the land parcels so that we also see how developments agree with the land data? Or what were the challenges why you could not include the parcels into the analysis? Thank you.
Yes, so as you said, there was a challenge when it comes to obtaining the parcel, and initially that was my idea, to take the land parcel and try and link it. However, when I went to Survey of Kenya, I found that it would have taken me a bit longer to try and get each and every parcel for each area in Upper Hill, so that then I'm able to link development, because my main study was not mainly saying that this particular parcel has developed to this particular level. However, to tie into that, globally there is a particular way. For example, if you want, for example, I've forgotten the name of this. I will check it out online. But the grid-wide method of analyzing development. And this particular grid-wide method would allow it to be used, for example, not only locally, like in Upper Hill, but can be extended over a very large area. And why I say that is, you're looking at a particular space, an area. So if it is 90, the grids that I used were 90 by 90 meter. 20 years to come, the same grid is what will be used for analysis to find out that particular change within that particular area and space. So it is not based on, for example, if that piece of land, let's say right now, mostly, let's say it was a quarter acre and it changes to, let's say, an eighth. So the point of reference has changed because of the subdivision. However, if you use a grid, 20 years to come, the same grid will be used. That's what they use in Europe. They have a grid-wise system such that regardless of how long later on you will be analyzing exactly within the same grid and within the same space. And that was one of my recommendations, that we can come up with a particular grid that would be used and would allow one to measure out the changes that have occurred within that grid. So the grid does not change whether subdivisions occur or any other thing. So that was my focus. However, when it came to land parcel, based on the challenges that I faced, I went for the grid-wise method of analysis.
Okay,
Maybe just before you move to the next person, sorry, Dr. Oloo, it's good you use the grid-wise method, but you know development is individual driven. I might be having a 1 acre land in Upper Hill, and I'm driven to do apartments. So I see that in terms of change detection, we should also incorporate the subdivision aspect, because it drives development. As opposed to it really drives development. So maybe it's a way we can going forward. We can look at how we can integrate the individual subdivision towards the development side. Thank you.
Okay, thank you, Malachi.
Okay, thank you. I also have a couple of questions. One is for students who are just starting on remote sensing. And you talk to us about urban remote sensing. What is it that they should look for in the remote sensing data to decide which particular data sets to use? Because normally when people are introduced, they're introduced to Landsat, ASTA, and sometimes they want to do such things and they just think they can use whatever is available. What is it that the students can use to decide what remote sensing data they can use for their particular applications? And then related to this, and it's a question that somebody has asked, is it possible at some point to codify what you've spoken about into even if it's a self-driven tutorial, that somebody can read that tutorial and go through the things that you've gone through and be able to have an understanding of what you're talking about? Then finally is on because the reason why we do research, the reason why some of us are even here is so that we see how can we move from the knowledge that is published to policy. And it may be related to the question that Michael asked initially. How can we move from this knowledge that you've now generated, in your view, to a policy that appreciates sustainable development, but also ensures that the environment is well managed and the quality of life in urban settings is good for all of us? Thank you.
Okay. the first question on how to know what remote sensing data would want to use, what I would say is about the scale of analysis. For example, my area of study was more of integrating geospatial technologies and planning at the same time. So it was the two of them merging together. So especially when it came to urban areas, I could have probably just settled for Landsat. Or for example, I had actually initially acquired Cartosat, but Cartosat became very difficult to try, and because one tends to be lighter and the other one tends to be darker, trying to create a 3D or trying to extract the building footprints became a bit of a challenge. So initially, yes, Cartosat was good, but it became very difficult because it was quite coarse. It has a spatial resolution of 2.5 meters, but that was too coarse for the kind of work that I wanted to do. So therefore, that meant that I needed to repurchase another one, and this one was from Ramani at 10 centimeter. So when it comes to remote sensing data, you look at the purpose. You look at, will it give you the kind of information and to the level of accuracy that is required? That is one thing I can talk about. So remote sensing, what do you want to do with your data? On fact of a tutorial, that is something I had not thought about, and it's a good suggestion. So, so that's something to think about, and I think probably I'll talk further with Francis on that. Then how do you go from knowledge to policy? This is one thing that I know has been a big challenge, and that most of us, that especially in the academic section, because there's a lot of research that has gone out and there's need for policy. And this is why public engagement is very key. And awareness about the implications of some of the decisions that are being made on the ground, and trying to tie that into the changes that we need to see, especially in our country and in our nation. So I can still say that is a direction, and it's still a challenge, but I can say it is still going out there, getting engaging, especially with policymakers, getting people to know what you have done. You've done a project, and you need to, for example, it's a project that you've done. If at all you don't go out there and let people know what you have done, and especially those who are involved in the key and decision making, then it means that then people will not really know what you have done. So one of those things is a lot of engagement, and that is how a lot of things that have moved from barely knowledge have moved into policy.
There's another question on whether the methods that you've applied can be used on urban informal settlements, and what will be your view? And then I think now we are coming to, as we come to a close, I also want you to comment to, because you've studied here, you've studied in Europe, and obviously there are differences in terms of availability of data and resources and the methods that people can use. So what will be your encouragement, your word to students who are here, who are trying to be experts like you are now? What are some of the key things that they need to consider even as they learn about geoinformation? And yes.
Okay. Yes, so this can be used in informal settlements. That the studies that have been done, and the studies that have been done nearly, I can say, for informal settlements that are there. And so of course, if at all you're going to be doing informal settlements, again, because of the material type and so forth, of course, a higher level of resolution. But at the same time, when it comes to informal settlements, what would you be looking at? You know, because there could be, in terms of what would you be looking at? Because there's something that you're looking at when it comes to the informal settlements. I think I would tie it into the previous question, the remote sensing data that you are getting. The particular type of study that you're doing, sometimes the data that you acquire because of the area that you're studying will tend to exacerbate the results that you get. One thing is about informal settlements, a lot of the roofs tend to be made out of corrugated iron sheets and so forth. So when it comes to the part of getting and acquiring high resolution data, for example, from stereo image, yes, you can get it. So I would say that the formulation of the problem and what are you trying to study in that particular area. So what are you looking for? So yes, you can try get it, but what is the main focus in it? That is it. And I can see, to understand, could this be used to understand change in informal settlement? Yes. When it comes to understanding change, yes, time series data is very important. You can use probably Landsat, depending on the, yes, you can use Landsat, or even ASTA, which has 15-meter resolution, or any other like Sentinel that is freely available at 10-meter. So you can still use it. So another one is, where can I get Cartosat? Cartosat, the company, is it IRS? Just write to that organization, tell them whichever area that you can get. So you can directly write to them and they will get back to you when it comes to Cartosat. So it's freely, of course you pay for it, so it's not free. Okay, so policy instruments push this to county GIS. Are they happy and willing to adopt this in their spatial plan? I believe there are counties. I've gone to some county offices and I can see them applying GIS, and there's a lot of great intake, and I can see there are a lot of partners that are coming in touch with county governments. So yes, there is. People are willing to use, there's a willingness, I can say, in county offices and county areas in integrating GIS in their plans, in urban planning, as well as in other in development as well. So in your question, the last question you asked about what I would talk about for probably students who wants to study, I can say just do not give up. For me, it took me a while before I was able to get an opportunity. But one thing is, as long as you have a dream and you have a drive, do not let it die because of one or two other things. So just keep at it. Take the opportunities that come to you. Just take the opportunities that come to you. That kindly just. Hello? I'll call you back later, please. Hello? So sorry about that. So mainly that is it. Take the opportunities that are coming to you with regards to it. Yes, so do not give up.
Okay, thank you. Any final thoughts or anything that you feel you should say, Patricia? Dr. Any final thoughts? Yes. Anything that you want to say before we close?
All I'll say is thank you so much for this engagement. I can see there is a lot that of interest in it, and I think this project was just the beginning. So I believe other people can take it further into other aspects, as has been talked about by Malachi, and look at it from a different angle. So I would say this is for everyone else to look at it from different angles. But it was good engagement. That's what I can say. And for the students that are here, explore out. There are very many tools, and there are very many, especially for me, it's machine learning. Get into machine learning. I think that is what I would say.
Okay. Yeah, so thank you very much. So Dr. Patricia is going to share her presentations with me. And so it means anyone who wants a share of the presentations, then I can be able to share with you. Maybe I'll write my email so that if you want to get in touch about the presentations today, then you can get in touch with me, and then I can also link you with Dr. Patricia. So thank you so much, Daktari, for the time, for presenting in a very clear way the topic that we presented today.
Excuse me.
Yes, Michael.
Excuse Daktari.
Yeah.
Yes, I raised my hand. I think you did not see it, but I wanted to ask that this was just a one-time kind of sharing knowledge, or is kind of an organized session that is going into the future? I did not get it clearly.
Yeah.
Yes.
So I'll share about that. Yeah. So thanks, Michael, for that. So this session was organized by a small company that I run. So for those who do not know me, I'm Dr. Oloo. I teach at the Technical University of Kenya. I also run a company that is called Geopsy Research, whose aim is to build capacity in such forums. Like I said at the beginning, this is just one. Maybe in the coming week or in 2 weeks' time, we will have another person. So the idea is normally to have practitioners in the field being able to share the experiences that they're having in the field and the work that they're doing in the field, so that we can be able to learn from each other, and so that we can be able to build each other's capacity. In some instances, we also organize these kinds of forums with students from the Technical University of Kenya. So it means in some sessions, it will be students from the Technical University of Kenya and myself organizing, so that because we believe that it is only in this way that we can propagate geospatial knowledge, which is indeed very good for the sustainability of our environment and the sustainability of the things that we do. I know we are coming to a close, but there's a hand that is been raised up very fast by Fabian Hillary. I don't know that, Fabian, you have something short to say or a question. Fabian, you can just unmute and ask or speak. Yeah.
Okay, thank you very much. So, I hope everyone is fine. My name is Fabian. I'm a student at Technical University of Kenya. So all along I've been thinking of as a student, actually I'm in my final year, and most students have approached me, especially from my class, to organize a talk whereby we get the practitioners in the geospatial field, whereby they come and mentor students and actually tell students on the real-world applications of geospatial techniques. For example, if one wants to be a programming student, if you get someone who can mentor him or her. If one wants to be, let's say, a land surveyor, you get one who can mentor. If one wants to be a specialist in remote sensing, he also gets one who can mentor him or her. So, Dr. Francis, I'm kindly requesting you to help me facilitate this, especially to the final years who are almost going out of the university. Because at this moment, you find some students that they still don't know what's outside the school when it comes to the spatial science. Thank you very much.
Yeah, so thank you, Fabian. I know we can directly speak because we are in the same institution. So it's a question about mentorship, and it is indeed true that it is people like Dr. Patricia who've been in the same institutions like you are, and who've been now out in the field doing research that could also be able to mentor. So it's something that we can talk about directly and plan so that there's a structured and organized way where practitioners in the field, for example, Dr. Patricia can have one of the students who is interested in a topic like this and mentor them through their research. So that's a possibility. We just need to speak and organize so that it's structured mentorship. because even for me and for Patricia and for a lot of people in our generation, we are where we are because a few people decided to hold our hands. So obviously holding other people's hands, because geospatial is not a very old field. It's not like philosophy or medicine. It's a field that is coming up, and definitely we need to depend on those who are ahead to hold the hands of those who are just starting up. So I'll get in touch, and then we can organize how to actualize this. Yeah, so I want to say thank you so much for the people who've come, and for the participation that you've been able to have. Very interactive, which is a good thing. So again, just be on the lookout, because like I said, maybe in the coming week or 2 weeks from now, we will have another session with another person speaking to us about another topic. And so just be on the lookout. Just in the same way you got the adverts, you will be able to see adverts around, so that you are able to attend. Dr. Patricia, thank you so much for the time. I hope you are not tired of our questions, and that next time when we ask you to come and do something, that you will still be available and willing to engage. And also following up on the question that that Hilary has asked, maybe once a country opens up and it's possible to have physical engagements, I know in future we could also just have physical engagements where you are able to practically show the things that you do and speak to students in the same space. So thank you everyone
Thank you so much
for it. So you can now leave at your pleasure. For those who have questions for me, yeah.
Sorry, Francis. So everyone will get my email from you, or I can type it on the chat.
It depends on what you are comfortable with. Are you comfortable? If you're comfortable, yeah. So you just put it in the chats, and people can get your emails and get in touch with you.
All right, thank you.
And once you share the slides with me, then anyone who gets in touch with me, I could also share the same slides with them.
Okay, then that is good. Thank you.
Okay, so maybe let's give it 2 minutes for at least people to see the email address, and then people can leave at their pleasure. So the email is there already, so you can note it down and get in touch with Daktari for further clarifications on these topics. Okay, thank you very much.
Okay, thank you.